Good morning to everyone. Today my presentation entitled New Type of Small Peptide Organocatalyst for Asymmetric Aldol Reaction of Various Ketone with Aldehydes. Introduction. A new type of novel peptide organocatalyst we are designed and prepared from commercially available chiral amino acids. The functionality of small peptide organocatalyst X we are examined in asymmetric Aldol reaction of various ketones with aldehydes. The catalyst X showed good catalytic activity in this reaction to offer the chiral beta hydroxycarbonate compounds with moderate to excellent chemical yield and stereoselectivity. The obtained chiral beta hydroxycarbonate compounds has found synthetic building blocks to prepare many biologically active and pharmaceutical intermediates. The previous reference, Hu and co-workers reported dipeptide organocatalyst for asymmetric aldol reaction. Using proline-based dipeptide organocatalysis for asymmetric aldol reaction of cyclohexanone with benzoaldehyde in the presence of benzoic acid in chloroform -20 degree 24 hours to afford the beta hydroxycarbonate compound up to 99% of chemical yield, up to 99:1 DR, up to 98% of enantiomeric excess. And Pasra and co-workers reported tripeptide organocatalyst for asymmetric aldol reaction. He also reported proline-based tripeptide organocatalyst for asymmetric aldol reaction of cyclohexanone with benzoaldehyde in the presence of toluene or water sodium bromide, 4-nitrobenzoic acid -10 degrees Celsius 24 hours to afford the beta hydroxycarbonate group, up to 99% of chemical yield, 97:3 DR, 99% of enantiomeric excess. My present concept work, we are design and synthesis common small di and tripeptide organocatalyst. Synthesis of small peptide organocatalyst 5A to I and 6A to J. The NBOC proline react with different substituted primary amine using acid amide coupling reagent DCC in the presence of DCM 0 degree to room temperature 24 hours to afford N protected Bach proline amide without purification, following by further reaction deprotection of N-Bach using TFA in the presence of DCM RT 3 hours. After affording corresponding proline amide, we coupled with different substituted chiral amino acids in the presence of DCC DCM room temperature 24 hours to afford the N protected dipeptide. Without purification, we followed by further deprotection reaction using TFA DCM room temperature 3 hours to offer the corresponding dipeptide organocatalyst. After affording dipeptide organocatalyst 5A to I, we use some of the dipeptide using further one more coupling of amino acids using same DCC and DCM RT 24 hours without purification, furtherly followed by deprotection of N-Bach using TFA DCM RT 3 hours to affording corresponding gamma 10 tripeptide organocatalyst 6A to J. After synthesizing di and tripeptide organocatalyst, which we examined screening of asymmetric aldol reaction of 7A cyclohexanone with 4-nitrobenzoaldehyde in the presence of diethyl ether 25 degree 24 hours to afford the beta hydroxycarbonate compounds. First, we tried dipeptide 5A to H for aldol reaction. In this condition, 5C showing 52% of chemical yield, 67:33 DR, 63% of syn isomer. Then followed by we modified a di to tripeptide organocatalyst. In this case, 6A to 6J. We tried the catalyst 6C showing 25 degrees Celsius, 25% of chemical yield, 20:78 DR, 94% of enantiomeric excess. After that, we changed the cyclic backbone 416 and the D-proline. In this case, D-proline showing 77% of enantiomeric excess, and 4-member ring 86% of enantiomeric excess, 6-member showing 90% of enantiomeric excess. After checking catalytic activity, then optimization of asymmetric aldol reaction condition of cyclohexanone with 4-nitrobenzaldehyde. We tried a different temperature, different solvent, and mole ratio of catalyst loading. In this case, we tried ethyl solvent, non-polar solvents, and chlorinated solvent and polar solvents. Then finally, we tried a solvent-free neat reaction condition. In the neat reaction condition, offered the 45% of chemical yield, 2278 DR, 87% of enantiomeric excess. But diethyl ether showing low chemical yield but excellent enantiomeric excess. Then after checking different solvent reaction, we concluded neat reaction is going well. Then we check a neat reaction 25° different catalyst loading 1, 5, 20, 30 mole ratio. In this case 30 mole ratio showing 85% of chemical yield and 96% of enantiomeric excess. Then we check 30 mole of catalyst neat reaction 0° and -25°. In this case 0° showing very good chemical yield 96% and 17 is 80 DR and 98% of enantiomeric excess. After optimization of different temperature, solvent reaction, and catalyst loading, we tried a 1 gram bulk reaction of 1 gram of 4-nitrobenzaldehyde and cyclohexanone using catalyst 6C 30 mole percent 0° neat reaction condition offer 98% of chemical yield and 93% of enantiomeric excess. Then we check best optimization reaction condition of asymmetric aldol reaction of cyclohexanone with 4-nitrobenzaldehyde using catalyst 6C 10 14A 14B. In this case also catalyst 6C showing very good result up to 96% of chemical yield, 17 is 83 DR, 98% of enantiomeric excess. Then the scope of aldol reaction of cyclohexanone with various aldehyde using catalyst 6C. In this case 4-nitrobenzaldehyde showing 96% of chemical yield and 98% of enantiomeric excess. 2-nitrobenzaldehyde 78% of chemical yield and 99% of enantiomeric excess. Meta-nitrobenzaldehyde showing 99% of chemical yield and 99% of enantiomeric excess. Orthobromo 30% of chemical yield, 86% of enantiomeric excess. Metabromo 48% of chemical yield, 93% of enantiomeric excess. The parabromo 63% of enantiomeric excess, 94% of enantiomeric excess. 4-chloro 57% of chemical yield and 98% of enantiomeric excess. 4-cyanobenzaldehyde 71% of chemical yield, 94% of enantiomeric excess. Simple benzaldehyde 30% of chemical yield, 60% of enantiomeric excess. Then we check a different kind of ketones, cyclic and acyclic heteroatom attached fused cyclic ketones. Then we tried a 5-member ring, 81% of chemical yield, 92% of enantiomeric excess. 7-member ring, 90% of chemical yield, 95% of enantiomeric excess. And 4-methyl 6-member ring, 70% of chemical yield, 90% of enantiomeric excess. And heteroatom oxygen attached 6-member ring ketone, 66% of chemical yield, 68% of enantiomeric excess. And again hydrogen oxygen attached heteroatom, 72% of chemical yield, 94% of enantiomeric excess. Ketone 68% of enantiomeric excess, 59% of enantiomeric excess. Acetophenone 67% of chemical yield, 92% of enantiomeric excess. The possible reaction course of asymmetric aldol reaction of cyclohexanone with 4-nitrobenzaldehyde using peptide organocatalyst 6C. The first, the condensation of N-terminal primary amine peptide organocatalyst 6C without aldol donor 15A forms a enamine as a intermediate 1. The conformation of intermediate 1 is fixed by gamma turn intramolecular hydrogen bonding interaction between the amide group at N-terminal side and the amide amino group at C-terminal side on the pyridine ring, and also the intramolecular hydrogen bonding between the N-terminal amino hydrogen atom and the next amide amino group of organocatalyst species. Intermediate 1 may be exist as intermediate 1, which is having less steric interaction than that of intermediate 2. Subsequently, more stable in amine intermediate 1 meet attack 4-nitrobenzaldehyde 16A through possible transition state 1 to transition state 4. In this transition state, the reaction may be proceed through transition state 1 to afford 2S3R 17A as a major anti-Aldol product, then those of transition state 2, transition state 3, transition state 4, wherein the substrate 16A have steric interaction from N-terminal side and the C-terminal side fixed by gamma-10 intramolecular hydrogen bonding. On the other hand, Aldol acceptor 16A 4-nitrobenzaldehyde meet coordinate with amide hydrogen atom through the hydrogen bonding at the N-terminal side on the intermediate 1 species in the transition state 1. Subsequently, the enamine moiety attack the anisotropic phase of 16A, resulting 17A as a major isomer of anti-Aldol products. In the conclusion, on the small peptide organocatalyst we easily prepared using the corresponding chiral L amino acids. The obtained small peptide organocatalyst 5A to I and 6A to J. We are employed in the asymmetric aldol reaction of several ketones with various substituted aldehydes. Particularly, catalyst 6C showed for most catalytic activity in this aldol reaction and offered the corresponding chiral anti-aldol products with moderate to excellent chemical yield and stereoselectivity up to 99% of chemical yield, up to 13:87 dia, up to 99% of enantiomeric excess. Thank you.